Welcome to Lecture 6 on Exceptions in Procedural Language Structured Query Language. Today we will explore how to handle errors effectively in procedural language structured query language programming. Any well-written program must handle errors effectively. In PLSQL, an exception is an error that occurs during program execution. Exceptions can be standard Oracle errors or user-defined. PLSQL provides the exception block to catch these errors. Exception handlers allow programmers to define specific actions in response to errors. This ensures the program runs smoothly or terminates safely. Using exceptions properly is essential for robust and reliable PLSQL programs, preventing unexpected failures and maintaining data integrity. In PLSQL, every program is organized as a block, which is the basic unit of execution. A PLSQL block has three main sections. First is the declaration section, which is optional. Here we define variables, constants, and user-defined exceptions. Second is the executable section, which is mandatory. This is where the program performs actions like calculations, queries, or procedure calls. Third is the exception section, also optional, which handles runtime errors. Using exception handlers, we can respond to specific errors or catch all unexpected issues. This block structure makes PL/SQL programs modular, readable, and robust, helping prevent errors and ensuring smooth execution. No application can work perfectly in every situation. Hardware failures, hidden bugs, or mistakes made by users can all cause problems. In PLSQL, any kind of error is called an exception, an abnormal situation that the program must handle. An exception happens whenever a problem occurs. There are different types of exceptions. Some come from the system, like not enough memory or duplicate values in an index. Some are caused by user actions, and others are just warnings to the user. By handling exceptions properly, your program can respond safely, avoid crashes, and continue running smoothly. In PLSQL, you can create your own exceptions called user-defined exceptions. These are defined in the declarative part of any block, routine, or package. Unlike built-in exceptions, user-defined exceptions must have names. Built-in exceptions are raised automatically by the system when a problem occurs. User-defined exceptions, on the other hand, are raised explicitly using the raise statement. You can also use raise to trigger predefined exceptions. This allows programmers to handle specific situations in their code, making programs more robust and easier to debug. In this PLSQL block, we first declare a variable called vnumCountries to store a number. Next, in the executable section, we use a selectCount query to count all rows in the countries table and store the result into our variable using into. Finally, we display the value of vnumCountries using dbms output.putLine. This simple example shows how to retrieve data from a table into a variable and then output it. Correct variable names are important, otherwise the code will raise an error. PLSQL provides structures to intercept and handle errors that occur during program execution. These structures are called exceptions. When a program encounters a specific error condition, the corresponding exception is raised. Handling exceptions is done in the exception section of a PLSQL block. PLSQL supports three main types of exceptions: built-in exceptions, which are predefined by the system; user-defined exceptions, which you can create yourself; and the others handler, which catches any errors not specifically handled. Using these mechanisms, PLSQL programs can respond safely to errors and continue running or terminate gracefully. Exceptions and their handlers are the way a program responds to and recovers from runtime errors. Runtime errors can include SQL errors like Aura001, which occurs when a unique constraint is violated. They can also include procedural errors like Aura06502, which happens when there is a numeric or value error, for example, a wrong number or value assigned to a variable. By using exceptions and handlers, A PLSQL program can detect these errors and take appropriate actions, preventing crashes and maintaining smooth execution. In this PLSQL block, we declare a variable name to store a last name. Then we select the last name from the employees table where the first name is John and store it into LName. The result is displayed using DBMS output putline. If the query returns more than one row, a too many rows exception is raised, and the program outputs a message suggesting to use a cursor instead. This demonstrates how exceptions help handle errors gracefully in PLSQL. In PLSQL, you can group multiple statements like several select queries inside a block with an exception section. For example, the no data found exception is triggered when a query returns no rows. This handler allows the program to catch such errors in one place. If you neglect to check for errors manually, problems may go undetected and cause other unrelated issues. Using exceptions, you can handle errors without writing many checks, improving program reliability. You don't need to worry about errors at every single point in your code. An internal exception in PLSQL is raised automatically whenever your program violates an Oracle rule or exceeds a system-defined limit. Each Oracle error has a number, but in PLSQL, exceptions are handled by name. That's why common Oracle errors are predefined as exceptions. For example, no data found is raised when a select into statement returns no rows. For other Oracle errors, you can use the general others handler. Inside this handler, the functions SQL code and SQLarm are very useful as they return the error code and the text of the error message. Using these tools, PLSQL programs can manage errors effectively and respond safely to unexpected situations. Table shows standard Oracle exceptions with descriptions. Types of standard exceptions shows in this second table. In this PLSQL block, we declare a variable NCNT and initialize it to 0. Then we try to divide it by 0, which immediately raises an exception. Inside a loop, we select each location.id from the locations table, adding 1 to the value. Each iteration has its own inner block that selects into NCNT. If no data is found, the no data found exception is raised, a message is printed, and the transaction is rolled back. The outer block has an others handler, which catches any other errors, rolls back the transaction, and prints a general error message. This example shows how nested exceptions can manage both specific and general errors in PLSQL, ensuring safe execution. In this PLSQL block, we first select the location ID from the locations table where the city is Roma and store it in the variable NED. Next, we try to insert a new row into the departments table with department ID 190. After the insert, the program prints inserted and commits the transaction. However, if the department ID 190 already exists, Oracle raises an error, ORA 001, unique constraint violated. This happens because the primary key must be unique. This example shows the importance of handling exceptions to prevent runtime errors in PLSQL. In this PLSQL block, we first select the location notch ID from the locations table where the city is Roma and store it in NID. Next, we try to insert a new row into the departments table. If the insert succeeds, the program prints inserted and commits the transaction. If the department ID already exists, the DUPH val on index exception is raised. In that case, we update the existing department with the new values, print updated, and commit the changes. This demonstrates how PLSQL exceptions can be used to handle unique constraint violations safely. In this PLSQL block, we first select the location or ID from the locations table where the city is Roma and store it in the variable NID. Then we try to insert a new row into the locations table using this NID, along with a street address, postal code, and city. After the insert, the transaction is committed. If any error occurs, the others exception is triggered. The program rolls back the transaction and prints a message. You can't insert a duplicated identifier into the table.
This shows how the others handler can catch any error and ensure the program remains safe.
In the first PLSQL block, we try to divide 100 by 0 and store it in a variable. This immediately causes a runtime error because dividing by 0 is not allowed. In the second block, we handle this situation using the zero divide exception. When the division by 0 occurs, the exception is raised and the program prints a clear message, "Error, you can't divide by 0." This example shows how exceptions let you catch errors and prevent your program from crashing. In this PLSQL block, we declare a variable init. We use a for loop to iterate over all rows in the locations table. Inside the loop, we try to select the department ID from the departments table where the location ID matches the current row. If any error occurs during this select, the others exception handler is triggered and the exit statement stops the loop. This example demonstrates how nested exception handling can safely manage errors inside loops, allowing the program to continue or exit gracefully when needed. Exceptions in databases are triggered automatically by the server during internal errors. Programmers can also explicitly raise exceptions using the raise command. The process involves declaring an exception, checking a condition, and raising the exception if the condition is met. Handling is done in the exception block. Syntax structure is crucial for understanding programming languages. It defines the rules for writing code, ensuring clarity and functionality. Proper syntax helps prevent errors and enhances code readability, making it easier for developers to collaborate and maintain software. In this PLSQL block, we first define a user-defined exception called E too much means salary. Next, we select the minimum and maximum salaries for the job stman into the variables v min salary and v max salary. We then compare these values. If the minimum salary is greater than the maximum salary, we raise the E too much means salary exception. If no problem occurs, the program prints the minimum and maximum salaries. If the exception is raised, the exception handler prints a message. The minimum salary is higher than the maximum. This example demonstrates how user-defined exceptions allow us to enforce business rules and handle errors gracefully in PLSQL. In PLSQL, the raise application error procedure allows you to raise a custom exception with a user-defined error code and message. In this example, we declare a variable nDepartment ID and try to select a department ID where the department name starts with A. If the query fails or any other error occurs, the others exception handler is triggered. Inside this handler, we call raise application error with a custom error code, 2000, and the message not found department. This allows the program to report meaningful error messages to the user and handle exceptions in a controlled way, improving program reliability and debugging. In this PLSQL block, we declare a variable nDepartment ID to store the department ID and a variable sertext to store error messages. We try to select a department ID where the department name starts with A. If any error occurs, the others exception handler is triggered. Inside the handler, we use the CQLarem function to get the error message text and store it in sertext. Then we print the message using dbms output.putline. This example shows how CQLarem allows you to display the exact Oracle error message, making debugging and error handling much easier. When developing PLSQL programs, always consider all possible errors and add exception handlers wherever an error might occur. Check input parameters carefully because they might be invalid or null. Queries may return too many rows or table structures might change over time. To handle this, use variables with %type and %row type qualifiers to match column types and store query results safely. Test your code with different invalid data to discover potential errors. Write debug information in your exception handlers, and if needed, store it in a separate table using a procedure with Pragma autonomous transaction. Finally, decide carefully whether each exception handler should commit, roll back, or continue. The key is to keep the database consistent and avoid storing invalid data, no matter how serious the error. Thank you for listening. We appreciate your time and interest in this topic.